Okay, so we've identified our anions, which are our negative ions, and now we're going to the other flow chart, which has at the top of it written cations, doesn't it? And it has at the top of the sheet the different possible ones. Okay, on our OHP we've cut off the top two because we're not going to demonstrate those. And Ms Thomas is going to show us the first step, which is adding.
Again, the same as with our anions, we take a small amount of our unknown sample, about ½ centimetre in that small test tube, and our test solution for most of our cations is sodium hydroxide. And we're going to add 2 drops of the sodium hydroxide and mix, and we can see quite clearly that we have got a precipitate formed in there that is not going to dissolve.
Okay, so it's an orange cloudy solution, and that flowchart now tells us to do the next step.
So we're going to take a new sample, so we're going to wash, empty that one out, and we're going to take a new clean dry test tube and take a new amount of our unknown solution. This time our test solution is called potassium thiocyanate, and again we're going to add just our 1 to 2 drops, and 1 drop is sufficient with this solution to give us a dark red solution. And to make sure that you can see that that is a solution, it is see-through. If we dilute it by adding water, you can see that that dark red colour is see-through.
And that makes it a...
It makes it a complex ion. So the iron 3 ion has complexed with the thiocyanate anion and has formed a complex.
And next?
Our next unknown is a blue solution. Again, we take a small amount of our solution into the test tube. We add 2 drops of sodium hydroxide, which is our test solution, and it's the hydroxide ion that is testing for our cation. And again, we can see we've got a precipitate. We cannot see through that mixture. So on our flow chart it tells us to take a new sample. So we tip that one out, put it into our wash container, again taking a clean dry test tube and a fresh sample, ½ centimetre deep, and we change our test solution to ammonium hydroxide, also called ammonia solution, and we add 2 drops, and we have a blue precipitate forming, which is not see-through. We then add excess of the ammonia.
What does excess mean?
Excess means we put plenty in so that we can see our precipitate is dissolving. And we can see we've got a blue solution, which is see-through, and there's a small excess of our precipitate at the bottom, but we've got this deep blue solution above it, which is the copper 2+ ion complexing with the ammonia.
Okay, so when we did that, we got a blue precipitate when we added the sodium hydroxide, which we have to name and write an equation for.
Yes.
And then when we got a new sample and added ammonium solution or ammonium hydroxide solution, we got another light blue precipitate. Do I have to write another equation for that?
We have to name it again, and we have to write the equation again, even though it's the same precipitate. But the first time it was the sodium gave us the hydroxide to form the copper hydroxide, and the second time it was the ammonium that gave us the hydroxide to form the copper hydroxide. So yes, we do need the equation twice, and then the complex equation for the deep blue solution forming.
Great, okay. We just have half a minute left.
Okay, in the next episode we will look at our white precipitates, and there are a number of those, and we have to be careful with how we react those and make sure that we're mixing them so that we get the right iron, not the wrong iron.